Hello everyone. In this video, we're going to see another problem in power electronics. The problem statement is in the circuit shown, all elements are ideal and the switch S is operated at 10 kilohertz and 60% duty ratio. The capacitor is large enough so that ripple across it is negligible and at steady state aqueous voltage as shown. The peak current in amperes drawn from the 50 volt DC sources dash give the answer up to 1 decimal place. This is a numerical answer type problem. We need to find the answer and enter the answer in the given place. So this converter, the circuit diagram of the converter is shown here. This is buck boost converter. We need to find the peak current in amperes drawn from the supply. So the solution of the problem is given here. For the buck boost converter, we know that the output voltage is alpha Vs by 1 minus alpha, where alpha is the duty ratio. Vs is given as 50 volts and the duty ratio is given as 0.6. So we can find V0 as 75 volts. And we know that for ideal circuit, V0 I0 equal to Vs Is. So if we get V0 by Vs, we will get alpha by, which is equal to Is by I0 equal to alpha by 1 minus alpha. So substituting for alpha, we will get 3 by 2. And we know that Vs is 50 volt and V0 is 75 volts. And by using this formula, Is by I0, we can find I0 as equal to V0 by R, which is equal to 75 by R is given as 5. So 75 by 5, which is equal to 15 ampere. And by using this relation, that is Is by I0 equal to alpha by 1 minus alpha, we can find Is equal to alpha by 1 minus alpha into I0, which is equal to 3 by 2 into 15 equal to 22.5 ampere. Since the capacitor is very large, we can take IC as 0 at steady state. So we can write IL equal to Is plus I0. And we found Is equal to 22.5 and I0 as 15 ampere. So IL will be equal to 37.5 ampere. And delta IL is equal to, we know that for a buck boost converter, the delta IL, that is ripple current, will be equal to alpha Vs by FL. Substituting for alpha, Vs, F and L, we can find the delta IL, that is ripple current, as equal to 5 ampere. And the peak inductor current, we can find it as IL plus delta IL by 2, which is equal to 37.5 plus 5 by 2 equal to 40 ampere. This 40 ampere is nothing but the peak value of the current drawn from the source, because that is equal to IL peak. So the required answer is 40 ampere. Now we are going to see one more problem, which is a buck converter as shown in figure A below is working in steady state. The output voltage and the current, the inductor current, can be assumed to be ripple free. Figure B shows the inductor voltage VL during a complete switching interval. Assuming all the devices are ideal, the duty cycle of the buck converter is dash. This is also a numerical answer type problem. We need to find the answer. So the circuit given is the buck converter, and this waveform is nothing but the voltage, inductor voltage for one full cycle. And the inductor voltage during the on period of the switch, it is given as 30 volts, and the inductor voltage during the off period of the switch is given as minus 20 volts. It is asked that we need to find the duty cycle of the buck converter. So for this, we need to find out the T on and T off, or we need to find out the duty cycle, so that we can we need to find out the capital T or T on and T off, or T off, any one of that. So we know that for the inductor, the average voltage, it is going to be 0 for one full cycle, So if we find the voltage of the inductor for one full cycle, it is going to be 0. So we can equate the average voltage across the inductor as 0. And so for this given inductor voltage waveform, we need to find the average value. We know that for this waveform, the average value is 30 into T on plus minus 20 into T off. That is the average value. If we equate that value to 0, then we will we'll be able to find out the value of the duty cycle. So for this one, the VL average is 30 into T on minus 20 into T off equal to 0. 30 into T on can be written as alpha into T, because we know that the duty cycle is T on by T. So we can write T on as alpha into T, and that can be equated to 20 into T off, and T off can be written as T minus T on. So we can write T off as 1 minus alpha into T. So substituting all this value, and we can segregate the alpha terms, and we can solve for alpha. So 30 alpha plus 2 alpha equal to 20. So 30 alpha plus 20 alpha, not 2 alpha. 30 alpha plus 20 alpha equal to 20. So we will get 50 alpha equal to 20. So alpha is equal to 20 by 50. So the required answer is 20 by 50, which is equal to 2 by 5, which is equal to 0.4. So the duty ratio is, duty cycle is 0.4. Thank you.